Welcome, everyone. In this session, we're going to explore measuring risk and return. By the end of this presentation, you'll understand the key concepts like the components of return, how to calculate holding period return, and the relationship between risk and return. So let's dive in and demystify these important topics using some real-world examples to help ground our learning. And we have many learning objectives, and all of these have to deal with calculating returns, understanding the relationships of those calculations. We also want to talk about risk, how we measure risk, and ultimately the connection between risk and return. So let's think about the components of return. Returns on investments come from two main sources: income and capital appreciation. For instance, if you own a share of Apple stock, you might earn income through dividends and see capital appreciation as the stock price rises over time. Combine these together to form your total dollar return. Now, if you bought Apple for $150, sold it for $170, and earned $3 in dividends, your total return is $20 price increase plus the 3 dividends gives you $23. So again, income is generated by the asset while we own that asset. A good example of this would be dividends and or interest. Capital appreciation is the difference between the purchase price and the sales price. The combination of the two creates what we refer to as the total dollar return. So what is holding period return then? Holding period return is the calculation, if you will, of the percentage return. Now we have Walmart here. We can determine the return for this day for holding Walmart stock as shown in this graphic. So the current price is $149. Excuse me. So as we express this as a percentage of term. So if you put $1,000 into Walmart and then sold it for $1,100 while earning $50 in dividends, your holding period return would be the dollar return, $1,100 plus 50 minus 100, so it would be $150 divided by the $1,000 price gives us 15%. So this formula is vital for comparing returns across different investments and different time periods. Putting this in a more formula sense, if you will, and looking at a spreadsheet calculation, here we bought a stock for $10 and we earned 60 cents in dividends and we sell it at $12. So what is the dollar return? What is the holding period return? And what if that holding period return was 3 years, not 1 year? So it's important to be sure and indicate the time frame of the investment. The return above doesn't consider time value of money. But the holding period return, HPR, annualizes that or incorporates the time value of money. So if we put $10 in, we earned $12 when we sold. Cash flows were 60 cents in dividends. Time horizon, 1 period or 1 year. That's a 26% return. Now again, what if we held this for 3 years? It took 3 years for this to happen. Putting in the time horizon, again, incorporates the idea of time value. So in this case, we would average 8.01 dollars or 8.01% per year. So if we're comparing investments, we want to be sure to have similar annualized returns. We want to annualize the returns rather than use the dollar return. So where do the returns come from for stocks? There are two different components. The dividend yield, that's D1 divided by the current price. That's the return earned on the current dividend payment as related to the current price. So essentially, if you bought it today and you receive this dividend at the end of the year, that's your return for the year. The capital gain piece represents the change in price, where G is the capital appreciation. This is, again, the change in price over the time frame that we expect or that we receive. What is it for bonds? It's a very similar formula. The income portion is the coupon. That's the interest based on the par value of $1,000 divided by the price plus G. And again, here, that coupon is the annual payment that you would receive if you purchased the bond. So let's think about different ways to describe returns. Expected returns describes the return you think you'll receive if you buy the investment. This comes from your analysis. The required returns represents the return that you desire, again, based on your analysis of the investment. The realized returns represents the current capital gains on the investment. Again, this is recognized and then taxed when you sell the investment. So what do the returns of stocks and bonds look like in general? So here's a graph from Morningstar Direct that shows three different investments. So we have roughly for stocks, the average here looks like about 9.59%. Bonds, 5.59%. And then a balanced fund where we see here that is a 60-40 split between the index fund and the bond fund. As we can see from this graph, now stocks were around 9.59%, bonds averaged about 5.59%, 60-40 split, again, about 8.5%. Again, when we can combine asset classes, as we'll find, we will frequently get some type of diversification. So again, over the long term, what we find is that stocks outperform bonds. How can we calculate returns? Well, two ways we can look at historical data is we can calculate arithmetic averages and geometric averages. Arithmetic averages do not incorporate the time value of money. As you probably remember from a statistics course or somewhere back in high school, to find the average, you just sum the numbers, sum the returns, and divide by the number of returns. The geometric average is a little bit more complicated in that we have to find the product of 1 plus the returns, and then you take that to the nth root for the number of returns that we have. So again, the arithmetic average is calculate the simple average over multiple periods. Geometric average incorporates the compound returns. So here's an example. We have a series of returns for these 5 periods, if you will. To find the average, you sum them up and divide by the number. If we did this in Excel, you would just use the formula equals average, and then in parentheses, you highlight the column of numbers. For geometric average, again, we take 1 plus those numbers and we multiply them all together. You then take it to the 5th root and then subtract 1 for our 9.51%. Or what we could do here is something equals geo mean if you're using Excel, and then in parentheses you put the array. Now that only works when all the returns are positive. If you have positive and negative returns, we need to use a slightly more complicated formula, where again it's equals, and then in major parentheses here we have future value FV schedule 1 comma, then the array, 2 parentheses there, and then the caret for the exponent, 1 divided by n, the number of periods, minus 1. This will help us to deal with the negative, which we have a negative return here at the end. So we have another way of also calculating returns. It's called the probabilistic expected returns. This is where we're going to forecast future returns and then the probability that those returns occur. So investing is all about predicting in the future. So how can we use this data to predict what an investment will earn us if we should actually invest? Now we'll be talking about this when we get to the specific securities later on videos, but we need to predict not just the returns themselves, but also the probability of those returns occurring. So again, here we have our same set of returns, but now we've assessed some probabilities. If you add these probabilities, they all add up to 1. One of the ways we can do this in Excel, it equals sum product, and then the first array is the probability, and then comma, the second thing that you highlight are the returns, and that will give us the answer of 3.55%. There's also a standalone worksheet that you can get from my class, and that's here. We just input the probabilities. Here's the asset, and that formula is right there where we calculate the 13.55%. So that's the first part of this video on risk and return. Look forward to seeing you in the next video.